So this is 1.1 statistics basics notes, and we're talking about two types of statistics, descriptive and inferential, and Liberty just told me to fill in these blanks with, for descriptive statistics, methods for organizing and summarizing information. Here's an example. Baseball decisions. Anybody go to the baseball game this weekend? No? I knew a couple people that went to the baseball game this weekend. During that game, data is constantly being created, right? Hits, misses, strikes, balls, home runs, all the different things. At the end of the game, there's a winner and a loser. All of this information is constantly being compiled by statisticians and then displayed for us to be able to understand and be able to make decisions, right? Who's going to go to a playoffs, right? Who's going to go to the postseason? So that's just data that is being created and organized and summarized. It includes the construction of blank, blank, and blank. Hannibal. Graphs, charts, and tables. All right, great job, Hannibal. And the calculation of various descriptive measures, such as averages, measures of variation, and percentiles. Those are things we'll learn more about in Units 2 and 3. Inferential statistics, other branch of statistics. It's utilizing information collected from blank. Can anybody fill in these blanks? Aaron? Great. I think it's phrased slightly different in your book. You're utilizing information collected from a sample of the population to make projection about the entire population. In other words, a conclusion that is drawn about a population based on a sample of that population, like we saw in our opener. Also, in 1948, there was a presidential election, and they took a poll. Who would you vote for? Who are you planning to vote for? And they compiled that information, and they printed newspapers because they thought that their survey was so reliable. They predicted that John Dewey would win the election, and we do not have that as a president. The president that was actually elected was Harry Truman. So we have an inference that was made based on a sample of the population, and that inference happened to be false. Inferences aren't always false, but in that case, it was kind of a big deal that they printed newspapers saying that there was a president that didn't end up being the president. So that's inferential statistics. This second part here is talking about follow this. This is tricky because I rearranged things and the picture wound up smack in the middle of my fill in the blank sentence. So this should say population and sample. That should be the title. And then, ready for this? Population, the collection of all individuals or items under consideration in a statistical study. In the case of the election poll, the population is blank. It is all voting age Americans. The population would be all voting age Americans. And then the sample, the part of the population from which the information is obtained. So in the case of the election poll, the sample would be those that were surveyed, or those that were polled, just those that were polled. I put that picture in there, now you can't miss it, it's right in the middle of the sentence, because I think it's a good reminder. Sometimes we mix up what's the population, what's the bigger one, what's the smaller one. The sample is the smaller one being taken from the bigger one, the population. last two definitions. We have observational study versus design experiment. I have some blanks again for observational study. Have you gotten one yet? Mac? Do you like to be called Mac? Okay, Mac, can you fill us in? Thanks. Observe characteristics and take what? Measurements? Thanks. So someone is blank data that already exists. Someone is simply observing data that already exists. I could observe how many people in the classroom have sandals on right now, and I could count that up versus those that don't have sandals on. That would be data that I am observing. That'd be an observational study. Design experiment. Anybody have the blanks for us on that? Mac, you've got it.
Researchers impose treatments and controls and observe characteristics of measurements.
Great. And then what? And then observe characteristics and take. Great. So do you take measurements in a designed experiment or an observational study? Yes, both. You're right. You did not fall for my trick. So you can't rely on taking measurements to determine if it's an observational study or design experiment. The unique thing about a design experiment is that it imposes treatments. Mac? So right now, I just did a social experiment where I asked for volunteers and gave candy if you answered. And I was curious, would that increase the amount of people volunteering to give answers? Yes, it did. So earlier, I didn't give candy, and there were some volunteers. Then I gave candy, and there were more volunteers. So you could say I just did a design experiment. Very, very, very simple, right? But I imposed a treatment. What was the treatment?
Candy.
The candy. Super simple. Okay. So it establishes blank and blank, cause and effect. A design experiment establishes cause and effect. I didn't actually have data until I did the experiment, right? So the data doesn't exist until you do something that produces the data. The observational studies can reveal only association, and whereas design experiments can help establish, I haven't heard from, did you get one yet, Casey? Casey? Causation. Excellent. Your homework on this section in Math Excel is due tomorrow by 11:59, but it's currently already available in Math Excel if you wanted to get a head start on it.